Are you tired of searching for custom ComfyUI nodes that aren't exactly what you're looking for? Why not make your own that fits you perfectly? Hi, my name's Cody, and I'm a software engineer. In this video, I'll teach you how to create your own custom ComfyUI nodes so that you can level up your image generation workflow. By the end of the video, you'll have your very own custom node and know how to read some basic code so that you can evaluate the stuff you find online. If you want to skip all the preamble and explaining I'm going to do, feel free to go to the chapter in this video called Building Your Own Custom Node. But if you get confused or you want some more information on the fundamentals, come back here and watch the video all the way through. All right, here we have the image sizer node that we're going to be talking about in this video. And let me tell you about why I made it and what it does and why it's useful. So I'm sure you've experienced in ComfyUI, if you don't have any custom node like I do, you have to come up with a width and a height for all your images. And the things you need to consider here are what sort of model you're using. If you pick the wrong resolution with the wrong model, you'll get weird things like funky hands or heads coming out of places or just stuff that doesn't seem like it should be there. And we also need to consider the aspect ratio of the image. Do you want to create a square? Do you want to create a portrait or a landscape? Stuff like that. And so my image sizer node takes all of that stuff and rolls it into one place. So rather than having to memorize some specific resolutions or do math every time you want to get some interesting result, you can just feed all this to the image sizer node and it will do it for you. You can see we have SD and SDXL. That'll control the pixel density of the image and make sure you're not going to get any weird results. And then also the aspect ratio. So super simple, no more manual calculation. And let's see, so I made a square here on the right side. Let's make more of a landscape and make it a 2x1 image. And there you go, so easy. I don't have to mess around with any image sizes or calculations, anything like that. I love it. So let's get into how we build this and what it's going to take. So to begin, we're going to need ComfyUI somewhere on your computer, and we'll need a text editor to write the code that will make up our custom node. Those are going to be our requirements. We need ComfyUI, and we need a code editor. Right here, I'm actually using VS Code. I like it a lot. It's very simple, but every programmer has their own favorite editor. And then before we really get into it, I want to talk about some tips for programming and sort of ways to think about programming so that you will continue with it and not get overwhelmed or frustrated. So firstly, know that anybody program. I've found that reading things on the internet, looking at Reddit, boy, there are a lot of people that say only smart people can program or only people that are good at math can program. That's totally not true. Anybody can do it, and I'll show you how. The easiest way, you go into your browser. I'm on Windows. You can do Control-Shift-I as inspect. It'll open up the Chrome inspector. That's what's here. And then down here you have your console. This is sort of an interactive programming environment. And I can type 2 plus 2 and it will give me 4. There you go. I just wrote a program. You can do that too. Anybody can do that. Everybody has a web browser. Anybody that says you can't program, they're full of it, right? You just did it right there. Now, it does take a lot of time and experience to be a good programmer, but making cool stuff, making stuff that's useful to you, you don't need to be a good programmer. You just need to get it to work, right? So keep that in mind as you build these custom nodes. I bet you'd be surprised to see the quality of a lot of code that's out in the world. Most of it, it just works, but it doesn't look very good. So don't feel like you can't do it or you shouldn't be programming. You're here for a reason and you should be programming. You want to do something fun. All right, next one, number 2, when you're programming, start small, really small. As you're learning, you will find that you're going to come up against blockers, you're going to get frustrated, you're going to get demoralized. That's just how the process of learning goes. Unfortunately, programming tends to be a place where when you do something wrong, it's not very obvious what happened or why it happened. And so the smaller your steps are as you're learning, the easier it's going to be to figure out what went wrong. You do a whole bunch of stuff at once. Well, do you know if it's the first thing or the third thing? You know if it's your editor or something else that caused this problem? If you start small, you only do one thing at a time before you check your work. It'll make it so much easier to figure out what's going on. And then relatedly, you really want to constrain your scope as you're learning. So the world of programming is vast and essentially infinite, and every day somebody's adding new knowledge to this universe of programming. And so that means you literally cannot know it all. And there will always be somebody smarter than you. And if you think about that for too long, you'll feel bad. That's a really common thing with programmers. Everybody has imposter syndrome because the vastness of the knowledge that's available compared to all the stuff that you actually have in your head. So constrain what you're going to learn and keep it small. So here today, we're looking at ComfyUI, we're going to be looking at Python, and we're going to be looking at how to create a custom node. So things that we're not looking at, any other frameworks, any other ways to write code, any other languages. We're not looking at JavaScript or Ruby or anything like that. We're just looking at Python. And we're looking at Python in this particular example. There's so many ways to write Python, so many things you can interact with. Right here today, we're only looking at ComfyUI nodes. And I guarantee you, if you Google any of this stuff, you'll get just so much information. It can be really overwhelming. Try to constrain the problem that you're working on because it will make it so much easier. And then thirdly and lastly, do something you love, programming. This is really important as you're learning. Programming is sort of a frustrating experience when you're just getting started because the error messages are so hard to work with and the computer is so bad at telling you what's going on. And it's so different than what you normally do in your regular life. It can feel really frustrating and you get stuck. You need something that will carry you through and make sure you love what you're trying to do. So for example, we're building a ComfyUI custom node. And I just think image generation is so cool. I feel like a wizard when I make a new image. It's incredible. Nobody in the history of the world has ever been able to do this. It's so neat. And that is the thing that sort of carries me through all these weird errors and the bugs that I find in my programs. Find something that you love and stick with that versus trying to make something big or something that other people will love or will make money. That, at least for me, is not motivating enough to get through all these frustrating little bits. Got to be something that I, really want to use and really want to see in the world, just for me, not for anybody else. All right, let's get programming. First thing to do here is in VS Code, let's make sure we have opened up our ComfyUI directory and that we're in the custom nodes subdirectory. First thing to do is to open up our example underscore node.py.example. Get that opened up, close our file explorer. It's a little big here, so I'm going to turn the font size down just a little bit. Hopefully you can maximize the video. And I'm also going to make this window as big as possible. And finally, move our notes here. I'll take some notes to the right-hand side. All right, taking a look at our example here that comes with ComfyUI. This is a fully functioning custom node. First thing to note, it's a class. And a class, for all you non-programmers out there, is sort of like a unit in programming. It's one of the units, one of the fundamental pieces of programming. And this just happens to be how ComfyUI organizes things. So you can call your class, it turns out you can call your class anything you want, as long as it's in this folder here, in custom nodes. And you can even name your file anything you want, but it's a good idea to name it the same thing, right? This is called example node. This class is called example. This custom node that I made that we're going to be looking at is called image sizer, and the class of the image sizer also is just called image sizer. So good idea to have those all match up. Secondly, we have our init function. We have two things going on there. We have this thing called init and a function. Another word for a function is a method. Let's start with the definition of a function or a method. Same deal, close enough. There's some interesting details there, but doesn't really matter for our purposes. A function is a group of code. Basically, you can imagine that you can write 2 plus 2 and then write another line that says 4 plus 4, then write another line that says 8 plus 8. And that's just sort of one line after another. How do you group that stuff together? Well, the way you do it in Python is with a function, or also known as a method. And this is just one of them. So you define a function using def, and it looks like this. And you can also see another function right here called input types. And you'll see that our function here takes some parameters, also called arguments. You can tell there's a lot of different words for things in programming. The words mean different things, very slightly different things, but for our purposes, again, same deal. So we have our init function, our init method is defined right here on line 28. It takes a thing called self. Not going to get into what self is. It's a little complicated. We don't need to deal with it right now. And then you have a colon that says there's going to be stuff after this. And then we have what's called the function body. And here it just happens to be one line on line 29 that just says pass. And pass is a special word in Python that just says, I'm not going to put anything here. That's all it says. The reason you need this, if you took it out, Python would yell at you and say, hey, I'm looking for a function body here, but I don't see anything. So you got to put, put something. You could put 4 plus 4. That would also work. But pass just means skip this part, basically. So that's our function. It actually turns out we don't really care about init, but it's a good example to learn about functions and parameters and function bodies. Next, we can get into this one right here. We have a class method, interesting, called input types, and it takes an argument, it takes a parameter called s. Okay, so what's going on here? Let's break it down. Again, all these things we learned up here. This is a method or a function. This is an argument or a parameter. We are defining this. And then below is the function body. We have one interesting piece here, which is this at class method thing. That's a little complicated about what's happening. We don't have to go into it, but just know for our input types function, it needs to be, this is called annotated with an at class method. That just tells Python this is something special. Doesn't really matter to us why it's special, just know that it needs to be there for now for this input types function. And also notice that all of our functions are indented. That's really important in Python. That means that Python is white space sensitive, which is to say this space right here is really important. If it doesn't exist, then Python will yell at you. That is probably the source of a lot of errors with the beginning Python learners. In a lot of languages, it doesn't matter what this space is, but in Python, it does. It makes things look a little cleaner too, which is nice. So we have, this is a big comment. This doesn't actually, Python doesn't look at this. This is just for humans to read, just for us to look at. Anything inside of here, it doesn't matter. And then we have what's called a return statement. So most functions return something. They take some input and they produce some output. So the input that our function here, input underscore types, takes s, and it returns this whole thing. We can get into exactly what that is in a moment. Going on, are there any other interesting things going on? Okay, so we have, this thing, return types. Notice that this looks a little different. If I look at return types and I look at input types, notice how they're a little different, right? Input types has a class method annotation. It has a define keyboard def. We don't see any of that here. It's just return types equals something. That means that we know that this is a function. Well, this doesn't look like the same thing. So it's not actually a function. It's called an attribute. And what we can say is that classes have attributes. They also have methods, right? So a little simpler. The difference between these two things, they do very similar things, right? It's properties on a class. Attributes in Python are pretty straight up. They don't change, right? You notice there's really no wiggle room here. But if you look at the function can return a whole bunch of different things. You can imagine you could do a whole bunch of math up here, and that would maybe change the answer down here. Whereas there's not really any space for math. So you think about attributes as very simple functions. I think that's a good way to think of it. See anything else? We have some more attributes, another attribute. We have some commented out things. These, again, are things that Python will not look at and not run. The way you do comments in Python is with this hash here, put that at the beginning of the line, or you can do a multi-line comment like this with 3 commas or 3 quotation marks. Anything else? That sort of covers that. We'll get into details about all this, what all this is doing. And then we come down here. So remember how I said that white space is important. Notice that these things are not indented. That is important. That means that these things are defined outside of the scope of the class. All right, so I just said a couple things. Defined outside of the scope and then of the class. Okay, so what does it mean to be defined? That's basically anytime we tell Python about something. We say, hey, Python, we got something, we got an attribute, right? Remember, we don't have a def here. This is an attribute. We have an attribute called node class mappings. It looks like this. And then we say, hey, Python, we got another attribute called node display name mappings. It looks like this. That is a definition. And scope. This is getting a little complicated, a little into the weeds of programming. But notice how things are indented and how down here they're not. That means the scope of these things is different. For this example, there's some more complicated stuff there. It's not always the case. That's not always how it works. But for what we're doing right now, that is what it looks like. So notice we're indented and we're sort of indented under class. That means everything under here that's indented like this, that's within the scope of our class. And then we switch and we have no indentation. That is a more what's called a global scope or a more outside scope. This means this sort of lives in, how do I explain without getting into the details? Yeah, we'll just call it the global scope. That's a good way to put it. This sort of exists outside of our class. And actually, if you notice, right, our class is indented at the same level as these things down here. So our class and these two attributes exist in the same sort of place, if that makes sense. Whereas the stuff inside the class, that exists inside of the class, I suppose. That's sort of a tautology, but there it is. So the scope is sort of where things live. And where you can sort of conceptualize them as being. It's a little fuzzy there, if you really want to get into the details, but I think that's a good working definition here. All right, so we have the fundamentals down. Let's take a look at what's going on with all these things and what they mean to ComfyUI. So remember that this is custom to ComfyUI. This is exactly what ComfyUI is looking. This is not how things will look in other programs or in other languages. This is very specific to ComfyUI. So we're sort of constrained as to what things can look like and how ComfyUI will read this program. If we don't do it right, if we don't do exactly right, Python will yell at us, ComfyUI will yell at us, and it'll tell us about it. We'll get into what that looks like in a little bit. So let's take a look at what's going on. I find it really helpful to start. You can collapse things. That's really super helpful here. We collapse all this stuff. It becomes a little bit less complicated, a little easier to read. So we have input types. Oh, okay. So we're thinking about a node. And let's take a node here. We have our ComfyUI custom node. Well, we can see we have something called input types. Great. What's next? Oh, we have return types. Okay. We have this thing called return names. Maybe that's related to return types, I wonder. And we have this thing called a function. Ah, that has the same name. That's the same thing we were talking about before, function or a method. I wonder what that refers to. And then we have an output node and a category. And then we have a function called test. Okay, so let's go through these things one by one. Input types, return types. I hope that's pretty obvious. That is the input and output of our node. So if I go switch back to ComfyUI here, our inputs are model type, aspect ratio, height, right? Our outputs are width and height. That's all that is. Same thing with empty latent image, right? Inputs, width and height, and batch size. And the outputs are latent. Same deal. So every node, you need inputs and outputs because that's just how ComfyUI works. Then we have return names. That's related to our types, it turns out. You notice here in our example, we have returning a thing that is of type image, and we probably want to call it image output name. So if we were to uncomment this, ComfyUI would now look at this thing and say, oh, when people are reading it in the UI in the web browser, I'm going to call it image output name. So again, if we go back here on empty latent image, we have our width as an input, for example. That is going to be, if we look at the latent image thing, let's look at, we'll keep it in this example. That's going to be like an int, right? Width is going to be an integer. We should talk about types too. Types, or also called primitives. Those are good to look at. We have our width here. That's going to be an int, and it's going to be called lowercase width, right? And so the same thing here. Our type of input is image, and our name for that input is image output name. So for example, what would be a good, where's a good example of that? Image, here's an example. This is an image, has the same type we're talking about, but notice it is all uppercase. That's just what the default is in ComfyUI. So whoever made the VAE decode node did not bother to name the output. It's just named image, which in this case is okay. You know this is an image. There's nothing special going on here. But for like a width and a height, if these were just called int, they're both called int. Well, which one is which, right? You really want to name these things. So that's what return types and return names. While we're talking about types, let's talk about what that means in the context of Python and what that means in the context of ComfyUI. So we have some Python types and we have some ComfyUI types. They're also called primitives, same kind of deal. Primitives are the fundamental building blocks of programs in whatever language or framework you're using. Types are, you could maybe describe them as a kind of primitive. So in Python, some of the basic ones in Python and in all programming languages, we have an int, which is an integer whole number. These are all from sort of math, right? Remember what an integer is on the number line? It's 0, 1, 2, 3. Ints do not include decimals. Those are called floats. And there's a whole bunch of different ways to represent decimals in computers that have all these caveats, and they're sort of hard to explain. For us right now, it really doesn't matter. Just know that float is something like, 2.3, and an integer is just 2, right? The next big one is going to be a string, and that is like a word. And that looks like that. It has double quotes. So here's a string, and those are really important to ComfyUI. ComfyUI does a lot with strings. Notice that there's other things in here that you could maybe think of as words, but like aren't, right? So like here's a comment, not a string. Here's a function name, also not a string. It needs to be in double quotes in order for it to be considered a string. And they can only show up in certain places, right? So if I were to say, wrap this in double quotes, that's not valid anymore, actually. Can't do that. It has to be on the right-hand side of the equals. Let's see what else. Ooh, a good one here. Tuple. You'll see ComfyUI talk about this. This is just like it's sort of like a list. There's another thing called an array in programming, and tuples and array are very similar. There's some subtle differences in Python, but more or less you can just think about them both as lists of things. So for example, if we're going to make a list of fruits, this could be the way we do it in Python. If we're going to make a list of fruits, we're making like a list of strings, for example. We have like an apple, and then a pear, and then pineapple, and so on, right? And same basic deal for an array. We're just going to make a list of things. So this can have anything. This could have, these are strings. You could also do numbers like that. One thing to note with Python, the way you make a list of one element, these are all elements, is you say something like 1 comma, or you have your single element and then a comma. If you don't have the comma, it doesn't quite, Python doesn't know, are you talking about a list? Are you talking about something else? You got to put the comma in there to say, oh, yeah, eventually there's going to be something after this first element here. What was I going to talk about with ComfyUI? I don't know, not super important. I would say you can see here, we look at our return types and return names and so forth. These are all, see, look, tuples. Our function takes a string, and we even have some documentation that says function, the name of the entry point method. Output node, Boolean. Ooh, that's another good one. Yeah, that's another basic one. Bool, also Boolean. This is just true or false. That's all it is. Computers do a lot of logic stuff, and they need a way to represent true or false. That's called a Boolean. It's named after George Boole, I believe his name was, a French guy way back who sort of studied the truthness and falsiness of things and did a bunch of math with that. That's the basis of computers, essentially. So those are primitive types. Let's take a look at our methods and attributes and see the different things that they take. So input types. Do we know what S is? You know what S is for input types? It doesn't look like it. Also doesn't look like it's being used. So, I don't think we need to pay attention to that. But hey, we can check this out. We can read this. Return a dictionary which contains config for all input fields. That's another good one. Dictionary. That is this thing, noted by curly braces. A dictionary is the best way to describe this. It's sort of like a more complicated list. It's like a list with keys, values, right? So if I have my dictionary here, notice that we have the key required, and that points to another thing, which is another dictionary. And then we have this thing, image, this key image, and that points to a tuple with one element that is just the string of image. Or we have int field, and that points to a tuple with the first element being a string called int, and the second element being another dictionary. So dictionaries can be nested, denoted by curly braces, and they're really good for configs, stuff like that, right? This is a really good way to represent sort of hierarchical information and configuration stuff. So to give you a sense of just how dictionaries work, right? How we're going to want to access, let's say I had this dictionary and it was called dictionary, right? How would I grab the value for this thing? How would I grab 4096? That would be dictionary.required int field of the second element. We're going to get an indexing here. That's probably not worth getting into. And then dot max. This thing, It's a little advanced programming. Yeah, I guess we'll get into it. It's called zero-based indexing. I would just read a Wikipedia page about it. It's not complicated, but basically, in computers start counting at 0, whereas we start counting at 1. And that means that the first thing in a list, for example, so like we're going to ask for this thing, this is at position 0 instead of 1 because computers start counting at 0. And so furthermore, this thing is at position 1, not position 2, because again, computers start counting at 0. Very common in programming, just something you need to get used to. Unfortunately, there's no getting around that. Basically, every programming language does it like this. Let's see, what else? Let's take a look. Let's take a look at what's being returned here from our input types method. So this is going to return a config, and it's going to be a config for all input fields. Okay, so this is how we define what our inputs are. Really good to know. So notice we have a couple things that are required. We have an image, we have an int field, we have a float field. What else? Print to screen is actually not an input. It's just a sort of a debugging thing with ComfyUI that you can look into if you want to. And then we have a string field. So we're looking at this. It's going to take an image as an input. You have to define it inside of a tuple. Notice that as a string. And you can see up here, we have some input types that are defined in this example that ComfyUI will accept. We have a model, a VAE, clip, conditioning. You notice all these things are all sort of custom stuff you've seen in ComfyUI. A lot of these are not Python definitions, but are ComfyUI definitions. So if you want to, let's say, create a noodle from like latent to output latent into an input latent, you are going to have to define type as latent. That's how it works. That's how these colors happen, right? And if I like get rid of this noodle here, right? Ugh, there we go. Right? Notice how it like sort of grays out the other stuff, like latent image, that's available for me to hook into, and this one over here. How did it know which to highlight and like which ones are good? It's because of the type, right? Both of these have type latent, so does this thing. So that's how it knows which ones sort of go together. That's really important. What else? We have our input types. These are, notice, Python things, right? That ComfyUI has sort of adopted. Type can be a list for selection. So returns a dictionary. Key input groups can be either required, hidden, or optional. A node class must have properly required. That is this, right? So this could be required, or this could say hidden, or this could say optional. But you have to, it's telling you, must have property required. You have to have at least something in here that's required. You could say also optional. Then you could put some more stuff in here, and those would all be optional. But you got to have at least a required field. And then value input fields contains the input fields config. Okay. And notice we have a field name. So this field name is called int field, for example. And then the value of that is a tuple, where the first value is a string that indicates the type of field or a list for selection. Okay, so here's the type of the field. Perfect. For print to screen, this is the field name, and here is the possible selections we can grab. So these are not actually types when they're specified this way. This is like, oh, I can select enable or I can select disable, and I can only select one of those. That's when I have a field or a list for selection. That's the list. And then the second value is a config or type int, string, or float. So notice we have some like sort of extra stuff here for our thing that is defined as a type int, extra stuff called for float. These have this extra config here This just comes from ComfyUI, so we can specify, like for an integer input, what's the default? It's going to be 0, it's going to be 10. What's the min, the max, step? If I use the middle mouse button and sort of move my mouse to increase or decrease, how big should each of those increases or decrease be? We have this last property down here called display. So you can go through here, change these values however you want. Really useful for providing defaults, right? And same thing for the strings. You want it to be sort of a single line or multi-line, and then what do you want the default to be? So that's our input types. We've got this required thing, then each one of these keys is the field name, and then the value is a tuple where the first element in the tuple is either a type or a list of strings. If it's a type, then it can be any of these, int, string, float, or model, VAE, clip, and so on. If it's a list of strings, it can be anything. That's just the thing the user is going to see. And then if we have some of these special types here, int, string, or float, they can have sort of extra stuff like defaults and things about their display. So that's how you define your input. Return types, let's take a look at that. This is, instead of being the left-hand side, this is the right-hand side of the node. So what thing will it output? Again, if we go back to here, look at VAE decode, for example, the return that it has, the return type is an image. That's its output. So if we go back here, this example happened to have the same type of output as VAE decode. It's an image. And then we can also name it something. So in the case of an image, it's not super important, but maybe you have multiple images or multiple numbers, and you want to be able to tell what the difference is between them. You want to name them. And so if we had multiple returns, we could say that's like an int, and then we could call it a special number. Oops, that needs to be inside of the tuple, actually. There we go. So notice that our types and our names for the type need to match up. ComfyUI is going to go through both of these in order and look and say, oh, this one goes with this one goes with this, right? You have to have those all together. Let's look at function. That is going to define what function a ComfyUI is going to call when it looks at your node. This is kind of not important. You can just call it one thing and stick with that. So notice that this is called test here. Then my function down here that I've defined with def, that's also called test. So this could be called my method. And then you would have to call it my method down here. It can be whatever you want. I would just call it run. That's a really good way to name things. Everybody calls it something different, doesn't matter. Just call it something standard that makes sense and you can know what's going on. Output node, I am not sure. I think this defines whether or not the node is an output node. And the reason that's important is ComfyUI will sort of work backwards. So if we have like a save image here, this is considered an output node because it's producing some final output. And then what ComfyUI is going to say, it's going to say, find me all of the output nodes. Okay, we have one. And then it's going to go backwards and say, okay, it looks like I need to run this in order to get output for this thing. What are this thing's inputs? And it's going to go backwards again, and so on and so forth. And it's going to find all of the nodes that are parents of the output nodes. It's going all the way back. And then it's going to say, oh, here's the last one. Okay, I need to start with this one. And I need to start with this one. And it's going to feed them forward again. So that's why the output node designation is important if you're building something that is going to cause ComfyUI to actually do something. That's what the output node designation does. And then line 80 category. This is the menu that you're going to put your node in, right? So efficiency nodes, that's one category. Zerfu nodes, that's another category, right? That's what is going to show up in here. My custom node, I put it in a category Cody Custom, and it's called an image sizer. That's all that does. And then down here we have our function. That's going to take some inputs and return some outputs. Okay, so how do we do this function? How do we write this function? So first thing, I'm going to take self. We don't need to care about self. It doesn't matter right here. More complicated than it needs to be. And then we're going to take some inputs that we have up here. Let's get rid of this. And notice that these things are the same, right? Image, string field, int field, float field, and print to screen. Those all come in here. So those all need to appear. I personally like to keep them in the same order just to keep things organized. It doesn't look like you need to, but I think that's a good idea just to keep things sane. So those are our inputs. And then what is our output? We have originally just this was an image. And notice that is our output. We return a tuple, in there, remember? We need a tuple of image, and that's what we're returning. So our function, it takes some input, it does some calculation, it returns some output. That's all we're doing here, very simple. And you can have your calculation as simple or complicated as you want, right? Whatever you want to do, you have the full sort of scope and backing of Python to do some really interesting things. Really, really great stuff that can happen here. So that's our function. We can look at what exactly we do there when we look at our image sizer. And then we come to these things. Okay, so these are sort of special. Remember how I said that these are defined outside of the scope of our class because they're indented all the way to the left. Let's talk about what's going on here. We have some helpful comments, in fact. This is a dictionary. Remember, thing that is good for configurations. Dictionary that contains all nodes you want to export with their names. Names should be globally unique. All right, so notice this is a dictionary, and the way we say this is a dictionary from string to class. And it takes a name and then a class here on the right-hand side. So what this is doing is we need a name for our node, and we need to tell ComfyUI what the name for our node is. We do that on the left-hand side, and then we need to tell it what Python primitive, what Python object we're going to associate with that name. That's what this is. And this actually refers to this up here. So if we were going to change this to foo, class foo, this also needs to be named class foo. But notice we don't actually need to change the name, right? This is just for ComfyUI to use, and this is for Python. So that's the difference. Personally, just keep it the same. Way easier to keep things simple here. And then finally, node display name mappings. This is a mapping from this thing to the thing the user will see. Again, keep it simple. You know, we can call our class example. It doesn't really matter. But this eventually is what the user is going to see, and this needs to be the same as this. That's it. So you can do whatever you want here. Again, keep it simple. There's people can do crazy stuff, but it doesn't really matter, and it just makes things more confusing. Okay, so that's a rundown of our example node and what's called the interface or the API that ComfyUI is going to look for. This is how ComfyUI knows how to talk to this thing. We just described all the pieces. So in review, we have some input types. Those can be things from ComfyUI or things from Python. And it's going to return this method, going to return a config in the form of a dictionary with various keys and values. And then later on down here, we have some attributes, which are like functions, but a little simpler. They don't do any calculations. Some attributes, this one's called return types. It's going to return a tuple of types, where types are these things from up here. And then some names that we can call these so users don't get confused. We have a function. This is the function. This is how ComfyUI knows how to call your node and do some calculations. This and this need to be the same. We have our category, which is where our node will show up for the user when I do that right-click menu. And then inside of our function, it's going to take some inputs that we defined above and produce some outputs that we also defined above, and then do some calculations to get from one to the other. And then finally down here, these things are defined outside of the scope of the class and have to do with how ComfyUI will look at your node and how it will talk to it. So this is your node name, this is your class name. Again, this is your node name, and this is the name that people will see in the UI. A lot going on here. I know. If you miss anything, go back, rewind the video. I would probably not recommend looking up generic Python stuff about this. You're going to get so much more information than is necessary, and it will just be confusing. My one caveat to that, I do love using ChatGPT, and so you can actually copy paste this into ChatGPT and say, hey, explain this thing for me, and it will do a pretty good job. And you can ask it follow-up questions. Be careful not to go too deep. It's really easy to get overwhelmed. Okay, so let's take a look at our custom node that I made. We'll start with init. Again, this does nothing. We don't care about it. We have our input types. What are we taking? We're taking a model type, aspect ratio width, aspect ratio height. We go here. Hey, look at that. We have our model type, width, and height. Perfect. And what are these types? Okay, so we have SD, XD, SDXL. We go back here. Aha, there they are. Perfect. And then same thing. We got an int, another int, we have default, step one, display, number, all good stuff. We have our return types. Okay, so our image sizer is going to take in model type and a aspect ratio width, aspect ratio height. What should it return? Oh, we need it to return a width and a height for the image we're going to generate. Okay, so that's an int and another int. And well, we're going to call them width and height because make it less confusing. Then we have our function here. We're just calling run. And then you can name your category whatever you want. And then down here, where things get interesting, we take our model type, width and height, and we return two ints, a width and a height. We do some calculations. And if you do the math here, this is how you take total pixels, calculations, and eventually get to our final image width and height that is within our constraints for these things. Easy, done. And then we have our node class mappings for image sizer. So I'd recommend pausing the video, take a look at this, see how it applies to whatever you want to make. And if you haven't thought of a custom node that you want to make, think of something right now. Think of something really simple, like an image sizer. You could find a different way to do this. One improvement that I'd love to make to this is making it so that my width and height are multiples of 16, because the models tend to really like that. If there's sort of weird numbers in between there, that's not what they were trained on. Computers really like multiples of 16, multiples of 2 actually is how it works. So that's an improvement. I wonder if I could do that. Or perhaps there's another thing you could do with image sizes, or maybe you could do something with the clip text, and maybe you could add some new text onto here. Or, if I say like a foo bar, maybe that expands. Maybe I can replace foo bar with some big long prompt, and I can make a shorthand for that. That would be really cool. So there's all sorts of things you can do here. But I think I'm going to leave it here, and this is a really good overview of how to develop ComfyUI custom node and all the code and all the Python that goes along with it. All right, we have our custom node all made. Now the question is, how do we get it into ComfyUI? Well, the good news is if you did everything right, it should just pop up. And so I'm going to start ComfyUI here. And it's going to go through its start process. And we have all this other stuff from all the other nodes. Let's see, custom nodes, image sizer. You can see it actually showed up right here at the top, got loaded. Took 0.0 seconds, pretty good. And then to actually use it, we can say add node, whatever your category is, and then whatever you called it. Here we go, we have an image sizer. Love it. Now, that probably didn't happen. Probably what happened is there's some error, didn't work, whatever. And so let's take a look at what's going on and how we can solve some of those common errors, how we can what's called debug and troubleshoot our code. So let me get rid of this. We'll go back to our code, and let's pretend I made a mistake. Boy, a really common mistake that I've made a lot. What if I just miss, like, that should be, this should be a list, but instead I forgot the square brackets. Super common. I do this all the time. What's going to happen? So we just made a change to our code, and unfortunately Python won't pick it up automatically. So we've got to restart our ComfyUI process. So let's go ahead and do that. We'll click here, and let's see what it tells us. Fortunately, we've got all this junk here. I try to do Cody custom image sign model type. Yeah, see, that didn't work. There's our problem. This should be like sort of a list of selections I can make, and now it's, I don't know, not sure what that is. What the heck is going on? Okay, the way you debug this is by thinking about this thing right here. Where did I define this? Where does this come from? Go take a look at that. And oh, hey, look, I made this mistake. This should really be a list instead of just a plain tuple. Cool. Not a great example because honestly, if I didn't do this myself, I wouldn't have seen that and I wouldn't know it was the problem. Maybe let's try to find a better one. Um, we can do, ooh, let's get rid of this. We'll comment this out, and now Python doesn't know what that is. This is going to be a mistake in our function that we define that's going to do the calculations for us. We can get rid of the ComfyUI window, and we will restart it. Wait a little bit. Add our node. And let's, actually, it's already connected here, so we can get rid of this one. Remove, do this. Uh-oh, total pixels is not defined. All right, it gave us an error message. Excellent. Looks really scary. And let's take it step by step and see what's going on. The first thing you should do when you encounter an error is read the message. I know it's a lot, but it has literally all the information you're going to need. So how do we read this? Notice there's some sort of repeating pattern here where it says file, blah, 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 file, blah, blah, blah. Each one of these is sort of a section of this error message. And it's going to start from the top down. So here's the stuff that ComfyUI is doing. Here's some more stuff that ComfyUI is doing. So we can see get output data. And get output data is going to call another function called map node over list. Okay, and then it's going to call another function called results.append. And in order to do that, we have to call our image sizer node. And look, we even have a line number, and it's telling us pixels, total pixels.get of blah, blah, blah. And so notice that this thing is defined to this, or related to this thing. Look, it says name total pixels is not defined, and we're using it down here. Okay, so we're trying to do this, and it says, I don't know what total pixels is. Okay, so let's go look at line number 40. Line number 40 is right here, total pixels. Oh yeah, look, we're in this function. Oh, I commented this out. Okay, that's what's going on. So these error messages here are really going to help you out. The line numbers are really going to help you out. You have to read them carefully. But once you read enough of them, you'll sort of start to see the pattern here. Like here's an element, here's another element. And this is another thing that ChatGPT can really help you with. If you just take this whole thing and you paste it into ChatGPT and you give it the code that you have for your node, it'll do a pretty good job of pointing you in the right direction. This debugging stuff comes with experience, and at first I think it'll be probably pretty hard, but you'll see more of errors, more of the same errors again and again. You'll get better at recognizing what's going on. So that's one type of error. What other error can we do? So that's an error with like running stuff. Ooh, maybe we can say, what if we say like, just totally mess this up, right? Instead of an int, it's ASDF. That's not a valid type. So again, and notice in our console here, the errors get logged as well. So you're either going to get it in your process, in your sort of text output here, or you're going to get it in your web browser. You have to check both. All right, let's restart things. So remember, I totally messed up that type. Let's see what it does. Do we get any crazy error times? We did. Image size. There it is. Perfect. All right. Again, this got all funked up. It doesn't know what it is. That's a way. I'm trying to produce an error that will show up in the log. What if I say something like, instead of this, I give it like a, I just return like a string here. What's gonna happen then? Or like an return one. Hopefully that'll blow up in our console and we can sort of see what that looks like. Nope, didn't blow up. Okay, well, you can see that that sort of messed this thing up. Sometimes some of the errors you'll get, they'll show up here. That's all I'm trying to demonstrate here. Let's turn back the clock. Go. All right, I think I'll leave it there. This video is already pretty long. So in this video, we've learned the fundamentals of programming, and we've learned how those fundamentals can apply to creating custom ComfyUI nodes in Python with VS Code. Remember, if you get stuck, you're not alone. This happens all the time. It's just part of the learning process. Make sure to read the error messages and read your code. And if you really don't know what's going on, I love using ChatGPT to help me out and prompt me to give me the right answer. If you run into a problem that you really don't know about, feel free to leave a comment below. No guarantee I'll get back to you, but I will be watching those and see if I can help you guys figure things out. All right, best of luck. Hope you make some wonderful and really interesting custom ComfyUI nodes.